Hey there everyone, welcome back to the new episode of Walkthrough. In this video we're going to be dealing with test number 2 from Cambridge 8. As you can see on your screens, reading passage 1, it's about sheet glass manufacture, the float process. So basically it's not that much of a long text, basically one paper, two lists. We have table completion, and as usual we have true false not given questions. Alright, let's get started without even squeezing the time. Alright, we have two words. We have two words here, and then we have true false not given. I just really want to see what things are there. So the metal used in float process have specific properties. So I'm going to take that. Pilkington invested some of his own money in his float plant. Okay, so he invested his own money. How much do I want to see his own money? Pilkington's first full-scale plant was an instant commercial success. Alright, this is just some sort of really dramatic words that they pretty much the examiners are claiming. The process invented by Pilkington has now been improved. Okay, so the computers are better than humans at detecting faults in glass. Alright, so we'll pretty much start from the table. Early methods of producing flat glass. In this color, I'm just going to choose green. I'm just going to really process that through. Alright, so glass, which has been made since the time of Mesopotamians. It's really hard to pronounce these Latin names. And Egyptians is little more than a mixture of sand, soda ash, and lime, heated to about 1500 degrees Celsius. This becomes a molten mass that hardens when slowly cooled. The first successful method for making clear. Okay, there we go. We have the first successful method, and it's mentioning about the method number 1 for making clear. Flat glass involved spinning. All right, so we have involved spinning. So it was called spinning. So I'm going to take that for us, and I'm going to make it as, let's say, red color as usual. And what are the advantages? This method was very effective, which means advantages, as the glass had not touched any surface between being soft and becoming hard. So not touched any surface and between becoming hard and soft, so it stayed perfectly unblemished. So glass remained, meaning not touched any surface between soft and becoming hard. So it stayed perfectly unblemished. So the word unblemished means not spoiled, not touched. Didn't have any problems. So the word unblemished. So I just want to take that and highlight it as usual. Could produce glass sheets of varying something, non-stop process. Alright, so it's still unblemished with a fire finish. However, the process took a long time. Okay, so it took a long time and was labor intensive. So like could produce glass sheets of varying what? Alright. Nevertheless, demand for flat glass was very high, and glass makers across the world were looking for a method for making it continuously. So, making a continuously non-stop process, the first continuous ribbon process involved squeezing molten glass through two hot rollers, similar to an old mangle. So, could produce glass sheets of varying what? Really interesting one. So we don't know about the ribbon yet, so we want to see slow, which is, I want to pay attention to slow, processed a long time, and was labor intensive. I just want to highlight that here. I forgot about that for a second. Labor intensive. Okay, so I just want to highlight that as well. And ribbon. Alright, so and then ribbon, and then we have the word ribbon. Where do we have ribbon? So we have ribbon. The first continuous ribbon process involved squeezing. So ribbon could produce glass sheets of varying something. This glass so process involves squeezing molten glass through two hot rollers, similar to an old mangle. So similar to is somehow it kinda so far relates to varying, but not so much. This allowed glass of virtually any thickness to be non-stop, to be made non-stop. So it was non-stop. So therefore, just gonna take that off. And so could produce glass sheets of varying thickness, because it says virtually any thickness. So this is going to be the answer for us. Okay, could produce glass sheets of varying means different thickness. Is it how it's spelled? Right, that is how it's spelled. Okay, we're gonna take that as well. A non-stop process, so it means made non-stop, but the rollers would leave both sides of the glass marked. Glass was marked. Glass was pretty much marked, I guess. Yes, it was marked. Let's just take that as well. 20% of the glass rubbed away. So we have the word 20%. We have 20% of the glass, and machines were very expensive. So rubbed away 20% of the glass. There we go. Easy. So now we have the Pilkington's flat process. So melting zone. We have a cooling zone. We have two zones, and we have two circular shaped some sort of. We remember that number 8 was number 8. So let me just put 6, 7, 8. We remember that number 8. They were rollers, and okay, 6. But we're still left with 6. All right, something is getting into this cylinder shape, but we don't really know that. Pilkington's float process. Okay, let's go that. The float process for making flat glass was invented by Alistair Pilkington. This process allows the manufacture of clear, tinted, and coated glass for building, and clear and tinted glass for vehicles. Okay. Pilkington had been experimenting with improving the melting process, and in 1952, we have 1952, I guess we don't have anything. 1952, he had the idea of using a bed of molten metal to form the flat glass, eliminating altogether. So we have molten metal. I think that number 6 is going to be molten metal. Molten metal. To form the flat glass, eliminating altogether the need for rollers within the float bath. So pretty much rollers, something that is circular shaped. There we can see here rollers within the float bath. The metal had to melt at a temperature less than the hardening point of glass, about 600 degrees Celsius, but could not boil at a temperature below the temperature of the molten glass, about 1500 degrees Celsius. The best metal for the job was tin. Okay, the best. All right, so it's saying the best job for the metal was tin. So it's somehow describing the metal used in the float process had to have specific properties, because it is saying the best job was tin. So he's saying that other types of metals were not basically working. So the rest of the concept relied on gravity, which guaranteed that the surface of the molten metal was perfectly flat and horizontal. Consequently, when pouring molten glass onto the molten tin, so there we go. What it is saying here is that onto, above, we have onto. So when pouring molten glass, we have when pouring molten glass. All right, so it's not a molten glass. It's not molten metal. It's a molten glass. When pouring molten glass onto the molten tin, so we have again molten tin. Molten tin. All right, we have a onto the molten tin. So we have this keyword here. Onto means above something. So I want to maybe just take this red. The upper side of the glass would have been perfectly flat. So it's saying it should be flat, meaning straight. So if the glass were kept hot enough, it would flow over the molten tin again until the top surface was flat, horizontal, and perfectly parallel to the bottom surface. Once the glass cooled to 604 degrees Celsius or less, it was too hard to mark and could be transported out of the cooling zone by rollers. So once again, it could be transported out. So we have transported out by rollers. So yeah, so the correct answer was rollers here, number 8. So the metal used in the float process had to have specific properties. Okay, and we remember that there was a. All right. There we go. We have the metal had to melt at a temperature less than. So the metal had to melt at a temperature less than the hardening point of glass, about 600 degrees, but could not boil at a temperature below the temperature of the molten glass, about 1500 degrees, right? So the best metal for the job was tin. Therefore, the specific requirements or the properties for the metal used in the floating process was tin. So melting at the temperature less than the hardening point of glass, not boiling below the temperature of the molten glass. So basically they're saying that it was pretty much hard using different kinds of materials. So the best type of metal was tin to successfully finish the process. I'm going to choose a cyan color here. So I'm just going to say if it's that, then the answer is going to be true. I'm going to name it as T. Pilkington invested some of his money to own his own float plant. As we know, because why I'm doing this is that first I found the question number 9 in paragraph 3, and I basically know that true false not given questions, they follow the order. So I'm just going to continue reading because I read this part. Pilkington built a pilot plant in 1953, and by 1955 he had convinced his company to build a full-scale plant. So there we go. We have the answer number 10. So to say Pilkington invested some of his money in his own flat plants, but what is it saying in the paragraph is that Pilkington built a pilot plant in 1953, and by 1955 he had convinced his company to build a full-scale plant. So basically, the writer is not mentioning whether or not the Pilkington invested his own money to build his own flat. So the information is not given for us. So we're gonna take that but not given. Pilkington's first full-scale plant was an instant commercial success. All right. However, it took 14 months of non-stop production, costing the company 100,000 pounds a month before the plant produced by usable glass. Furthermore, once they succeeded in making marketable flat glass, the machine was turned off for a service to prepare it for years of continuous production. There we go. We have the next answer. So what is it saying? Basically, however, it's saying, however, it took 40 months of non-stop production, and so it took 100,000 pounds before the plant was produced any usable glass, and it keeps on going. When it started up again, it took another 4 months to get process right again. So that means the process of making flat glass was not immediately success. It was too long. So instant means happening immediately. You remember the word instant means it was happening immediately, but it is saying actually the different word. Commercial success, and of course commercial success we have we have the word succeed in making it marketable. So but the machine was turned off. So basically it wasn't instant commercial success. It was the opposite. So I'm gonna put F here, and I'm gonna let's take that. And all right, so we have number 12. The process invented by Pilkington has now been improved. Float glass today now. Let's read that. We're gonna start at the beginning. Okay, float plats. Today may go. Today is referring to now. So what does it say? Several process: melting, refining, homogenizing. So basically, float plants today make glass of near optical quality. It adds up. So it adds up to continuous melting process. And it's saying, look, it's saying several processes: melting, refining, homogenizing, were used in this process of delivering glass smoothly and continuously to the full glass. Bath. So from there to a coating zone and finally a heat treatment zone where stresses formed during cooling are relieved. So today, of course, it's going refining. The process invented by Pilkington has now been improved. Yes, the correct option is true. Computers are better than humans, so we have computers. The principle of the glass. Okay, I just really want to find the word computers. We have there we go. I found the word inspection technology. So inspection technology allows more than 100 million measurements a second to be made across the ribbon. Locating flows the unaided eye would be unable to see. So what is it saying? Is it true or not? Because we still have better than. What can we see here? So pretty much if there's a comparison sentence here, here it's saying inspection technology allows more than 100 millimeter measurements a second to be made across the ribbon, locating flows, which means mistakes, right? The unaided eye would be unable to see. So yeah, so a second enables computers downstream to steer cutters around the flat. So it's, yeah, basically true. It's not really that it's comparing or it is contrasting. It is just saying that it is just saying better than humans. They are saying that locating flows unaided eye would be unable to see. They are saying that the normal human eye cannot see the mistakes or the incorrect parts of that process, whereas inspection technology can. So there you go, guys. We pretty much finished it, and you can also get a new vocabulary for yourself. It's called unblemished. Unblemished means untouched, not spoiled. So there you go, guys. If you found this helpful, make sure to subscribe and hit that like button. And thank you very, very much for watching. See you on the next episode.